Hello world, I'm Nick, and in this video I'm going to talk about generics. I'm going to give you a basic overview of what generics are and give you an example of how they can be used. Before we get into the video, please don't forget to like and subscribe. It really does help the channel and it helps me to bring you more .NET content. So in CSharp you may have heard of things being referred to as object of T. This is the way we refer to generics essentially. So you've probably seen this a lot in C# already. For example, I can create a new list called myList, and that is going to be a new list of type string. In this case, .NET uses generics because it's a list of T being a string. And by that token, I can also say I want to create a list of file info, for example. So file info being an existing object type in .NET, but I can create a list of those thanks to that generic type. And this is what's called a generic class. So it's a class which allows us to implement a generic type. If we looked inside system.collections.generic, there we go. So the original .NET object is system.collections and then .generic. And the reason they've used this .generic is because they're using a lot of these generic type of T. So you can see it's inheriting from the interface iCollection of T. It's inheriting from iList of T. And we get a bit more information if we look further down, and this will be similar to the example that I'm about to create. But one of the members of list is a public T. So again, this is the generic that we're going to be passing in. And you can see it's referenced in lots of different places. So, you know, you've got all these different T's which can be passed in, which keep things generic. So it makes it so it doesn't care about the type you're passing in. So let's take a look at a quick example of this. If I want to create my own generic class, I can go outside the program class here in this console app, and I can say my generic class is the name, and then we can put T to say that this is going to be a generic class. And then just like any other class, I can give it a name. So I can say, or I can give it other properties like name, for example. So we've got a simple string here called name. And then what I want to do is give this a generic member. So you can see Visual Studio has already picked up on the fact that I'm using a generic class, and it's suggesting that I use public T value. I'm going to make that a little bit different and call it data, just because value can sometimes get a bit mixed up with other inbuilt functionality. Now the way this works is when I declare an instance of the class, of my generic class, I'll have to say that I'm using a new my generic class, but then specify a specific data type. So I could create a my generic class of type string, of file info, as I used in that example previously. What that means is this data field will have to be the same data type. So if I say my generic class of type int, then this T data here will automatically become an int. And I'll be able to refer to its usual int methods or functions as I would with any other explicitly defined integer. So let's see an example of this. So up in our main method, before we do a console read line to keep the application open, I'm going to say my generic int class equals new my generic class of type int. And so I can say my generic class.name equals test. Okay, that's fine. And then if I look at my generic class dot data, it's expecting an integer. So if I try to put my data as a string, well, it's not going to let me compile it because the generic that I've used as the type is saying no, this needs to be an integer. So I can change this to a 2 and it accepts it. So that's great. So that's one way I could set up my generic class. And just to demonstrate that that's using it correctly, I can say var result equals 2 minus my generic class dot data. And what I would expect to see here is that result is 0 because I'm just doing some maths. Run the app, look at result, and I'm getting 0. So straight away, the genericness of this is that data is just T, but because I've created a my generic class of type int, the data is an integer and I can use it and it's just understood by the compiler that I'm using an integer at that point. The other thing we can do as well is we can specify generic constructors. So if I wanted to build a constructor for my generic class, I can create a constructor in just the same way. So I can say public my generic class, so I just say the name of the class, and then I can say I want to have the name passed in, which is always a string, and then again Visual Studio is kind of showing this for me, but I can specify a type of t and then data. And so now whenever I do a constructor on this, I can pass through whatever data type I want, and it will get fed into this data, and that data type will be solidified. So for example, I could say name equals name and data equals data. So now this is starting to fail because it now requires a name parameter in the constructor. So then I can use the constructor, but one of the things that's really important to note is that you still have to specify a type parameter. So my generic class needs to be new my generic class, but notice that I can't just say I'm going to pass in string and then 2, and then it just accepts that it's an integer. I still have to say at the creation of the object what generic type I'm using, what type parameter is it. So I would say int, and there we go. That would allow that through because it would then turn t into integer. And of course, using that example of a more complex object, so if I say file info, and then I just say I pass in a new file info object, put in the name myfile.text. So you can see there, that's now just accepting file info for the data parameter. So, if I was to look at my generic class .data, you can see that I have the usual properties that I would have on a file info object. Now you may ask, what's the reason for using generics? And it seems to me to be sort of two key reasons why you would use them. The first one for me is the idea of being able to use type safe objects that would hold various different object types. So for example, with this my generic class, if you had a situation where data could be one of several different things, but you still want that type safety of being able to essentially say at this point it is definitely this type, then you've got that with generics. So it's always expecting you to define a concrete type. So it's a my generic class of type, and then you must specify the type. So it gives you that type safety whilst allowing you to be a bit more flexible about the types that are being held inside the object. The other reason I think is also performance. So when you're being a little bit more dynamic and you're throwing just generic objects around, so whenever you see the type object, that will have been what's called boxed. So when something's boxed, it's wrapped in a system.object type, which means that it's generic enough that it can just be passed around to different subroutines or functions or methods or whatever. So essentially, it's just very vague. It's just an object. But the problem with that is that when you have to actually do something with that object, so you need to get to its methods, its properties, its fields, and you don't necessarily know what those are, then you have to unbox it. So you have to turn it back from this generic object to the concrete type you want to work with. So if you were passing around a list of object, which I wouldn't recommend, and that list happened to have integers in it, or it had a complex object like person, for example, then you would have to unbox the objects in that list and essentially convert them back into the strongly typed person type, which can be very negative in terms of performance. Boxing can be expensive, whereas with a generic list or a generic class or using generics in general, there is no need for boxing or unboxing, and so you get some performance benefits from that. So as long as you know specifically what type you need to use, then generics are probably the way to go. There's probably a million other use cases for generics that I haven't talked about, so if you remember any, or if you're using them yourself, then put them in the comments below. If you want to hear more in-depth explanations of generics and how they can be used, then again, let me know in the comments and I'd be happy to do another video. Don't forget to subscribe and like this video, and I will see you soon for some more .NET content.